if you use for loop or while loop, you will get 5 points for sure, right? But if you use if or something, you lose 5 points immediately. No question asked about it. So you can see how important it is if you pick the wrong thing. Okay. Remember the whole problem is 20 points, right? And you just need to write 2 lines, 20 points. And just for and if, right? Just between for and if, that's the 5 points different. So be careful with that, okay? Be careful. I don't know, not many of you, but some of you, very few of you, just put an if there, or and that's, I totally don't understand. For the final exam, you really have to prepare much better than that. Okay, understand? Okay, so that's the first one. So easy, right? This is the initial. The initial value for I is 10, right? And then you will stop the loop when I get to 0, and then inside the loop you basically reduce it, right? And this part is nothing. I mean, you already know that's a 5 times I, right? Very easy, very easy. So I don't have to say anything more. I think this is so clear, just 2 lines. So let me move to the next one. Okay, so now this is actually the way you are familiar from C to assembly. And this is basically almost identical, almost identical to the one that I use in the lecture. So if you copy that one into your cheat sheet, I mean, you can do it extremely easy, right? So A is a register in register R1, B is in register R2, and of course you just compare them. And if it's greater than that, then you move 1 to C. Move 1 to C is R3. If it's less than that, move 0 to that one, right? To R3, that's all. The only thing maybe a little bit tricky over here is the unsigned. I asked you for unsigned number. So for unsigned, you have to use the suffix for unsigned, okay? For example, in this case, I use lower or same, right? Something like that. If anybody use for signed number, then you will lose 2 points, okay? Some of you use branch less than, for example. If you use that one, then you lose 2 points, okay? Okay, so let me come back. Matthew has some question over here. So for number 1, if we put either a while loop or for loop, we will get the points. Yes. No, I mean 5 points. 5 points. 5 points just for while or for. Okay. If you use if or something, you will lose 5 points. Okay. And for the rest of this thing, that will be the remaining 15 points. Okay. Okay. Understand? Okay. So this one you just need to trace. Okay, so G just has the question: could we use branch if lower? Yeah, that's the unsigned one, right? But in this case, had to be the same as well. Basically, if this is the condition for greater than, right? For this case, for the else, it had to be less than or equal. Okay, so you have to use branch less than or same, ls. Understand? Okay. So for this one, it's easy. Is that right? So you just just trace the value for R0 and R1, right? So first of all, the initial value for R0 is 3, and initial value for R1 is 33. Okay, and then you compare. Basically, this is the loop counter over here. You compare R0 to 9 to see if whenever R0 get to 9 or greater than 9, you stop the loop. You stop right here. If it's greater than or equal, you go to end loop. So you stop, right? If not, then you do what? So at the beginning, of course, 3 is less than 9. So we will do the loop over here. So we will subtract 33, subtract 3. So R1 will be 30, right? The first loop, R1 will become 30. And then R0 will become 6. Is that right? The first iteration. Iteration, R1 will be 30. And R0 will be 6. Is that right, William? Understand? Okay.
Yeah, but
so now go back here, do it again. So now you will compare 6 with 9. 6 is still less than 9, right? So we go into the loop again. So this time you will subtract 30 subtract 6, right? So it will be 24, right? And then you add 3 more to R0. So now R0 become 9, right? R0 become 9. So you go back to the loop over here and you compare. At this time, R0 is 9, right? So 9 is, 9 equals to 9. So that's why we end the loop. We jump out of the loop. So that's why the value for R0 and R1 is 9 and 24. Easy?
I thought, because it's greater than or equal to.
Yes, okay. Yes. Greater than or equal. So even at 9, it's already stopped, right?
Okay. I probably messed myself up in that I was thinking when they meant greater than or equal to, still
right. And
kept with 9.
And remember, this one is for this problem is graded automatically. So
I just went one.
After credit over here, if you put the wrong number, you get 0. Okay.
Yeah, I went one loop more than I should have. So.
Yeah. So be careful. Okay. Just a very simple two iteration, and you can trace and you can figure it out. Okay. So so for this one is easy. Is that right, everybody? This one is very easy. Is that right? Do I need to go over?
Probably a little bit of the linked register and the stack.
So, Sean, anybody, if you have any, if you truly believe that I add the wrong, kind of make a typo in your grade, send me an email, okay? And I will take a look again for your case, okay? So don't worry too much about it because your work is still in Canvas, so it's very easy for me to check, okay?
Yeah,
for this problem, let's see. For this problem, we start from the main function, 40A over here. Where's the main function? Oh, the main function from here to here. So start from 140A over here, right? And then we go to for C, and that's a function call. So we jump to foo. Where's the foo? Our foo is here. So that's the 150A, right? 150A over here. And then we just, in foo, we just go down the list over here. If we have another function call, we just jump, and that's all. So 150A for sure, and the next one will be 15C over here. And at this time, you jump. So jump to bar. So where's the bar? Bar is up here. So that's why this one is 130A over here. And then go down here is 113C, no problem. And then 140, no problem. And 144. 144 is basically a return, right? Return. So who called the bar? Here, right? So it will return to the instruction right after this one, right? So that's why it's returned to 160 over here, right? And then it will go, the next one is 64. And I just want to ask you up to this point. I don't ask more, right? So so many of you did this one very well, so no problem, right? So link register. Link register is to store the return address, right? So let's start from here. Main from here, 148, right? 148 over here. And then you want to go to 14C. 14C. This is a function call. So that's why you need to remember the next address, 150 over here. So the first time you push that one, the first time the link register has the 150, right? Over here, right? And then when you jump to foo, you jump down to here. And then you will have another function call over here, right? And when you have a function call over here, you jump to bar, but you also need to remember the next instruction address over here for you to return. So that's 160 over here, very easy. So you jump to bar, come to here, and you go down all the way, right? And return to here. Return to here, and then it will continue with this one. And this is another function call over here. And because this is a function call, it will remember the next address over here, right? So 168 will be there too, right? Easy. Okay, so this one and this one is easy. Okay, so now for the stack, for the stack, and remember okay, actually over here. Remember, I pushed the LR over here. Remember? So you can see that the first value of LR over here will be pushed onto the stack, the 150. And if you really trace, or if you really look at the example in the book, for example, it just puts the LR just one time, the value of LR into the onto the stack over here. So that's why 150 get to here. Okay, so that's very easy. Let me move to the next one over here.
The stack is just the address, not the value. Okay.
Yeah, the stack can be anything. Okay, the stack can be address, can be the value of a register. It's up to you. The stack is just a memory area for you to remember something. Okay, and when you're done with the subroutine, you just pop up. So it's up to you. Okay, so go to the true and false over here. I think it's very easy, right? To return from subroutine, of course. I mean, we never have an instruction return, right? I just trick you. I mean, to return from the assembly, you use a branch command, right? Either, for example, bxlr, for example, right? But not return. Okay. So number 2 over here, push is equivalent to store db. That's correct. However, pop is LDMIA, not I before. Okay, address will be increased after. That's for pop. So that's why the answer for this one should be false. Okay. So how about this one? In the case of passing argument to the other, when the caller pass 64 argument the address. Yeah, of course, this is apparently right. You use R0 and R1 to pass the arguments. Okay, understand? Because you have 64 bits over here, right? So 2 register will be enough for that. And then the return value. If you have 32-bit return value, you have to put in R0, right? If you have more than that, then you start to use R1, or if you have even more, will be R2 as well, or all 4, R0, R1, R2, R3, if you have 128 bits to return, for example. Okay. This is I just tricked you a little bit over here, but if you actually copy this one into the cheat sheet, you couldn't have make mistake over here, right? Because the condition over here, condition can be used for signed number. Yeah, lower or same over here. These surfaces are for unsigned, right? So you know that this is 4, right? The comparison, this one, of course, the behind the scene, the comparison here is basically R0 minus R1, right? And set the flag, okay? How about this one? One key motivation for using subroutine. Oh, clearly this one is true. Yeah, this is too easy. It's true. Okay, how about this one? How about H over here? To call a subroutine and go back to the caller function, bx label. Basically, you know what? This one I just switched to trick you, and that's all. So to jump to call a subroutine, you should use the BL label, right? And for return, you should use BXLR, right? I just switched the label and with LR over here. So this one definitely false, right? For this question, the assembly instruction here can be used to compare with -10. Yes, this one is of course. the purpose of the CMN is for that, right? Not compared to positive 10, but compared to negative 10, as I already said in the lecture, right? Okay, last one. For an assembly subroutine, link register LR doesn't need to be pushed onto the stack if the subroutine doesn't call. And this has to be true, is that right? Right? Because whenever you a subroutine, if a subroutine call another function, it will destroy the LR register, right? And that's why if the subroutine call another subroutine, you have to save the LR value onto the stack. But if your subroutine doesn't call anybody, then you don't have to save onto the stack because the return address will be in the LR register already, right? So you don't have to do that. Okay, so
what about? Sorry about that one, but what about if a subroutine is calling itself like what a loop does with branching?
Can you
like
repeat
like a factorial where you're basically calling itself.
In that case, actually, the subroutine is calling another function. It's calling itself, right?
Oh, so even if it's itself, it still counts.
Yeah, okay. If the subroutine calls a subroutine even itself, right? The LR register will be overwritten with the new return address, right?
Okay,
so that's why.
Right. I definitely overthought that question because I was thinking of something like a factorial where it's a function calls itself. It's not calling other subroutines, but it's calling itself. That's why I was.
Yeah, what I mean is calling itself, calling other subroutines, including itself. It's basically calling another subroutine, right? Either subroutine itself or not, right?
Yeah, okay. I overthought that one.
Yeah, let me come back to. Let me come back to the
okay
question. A few questions that you have over here, Joshua. If f in phi, I put false because I thought it was incomplete because it didn't say it update the flag. Oh, actually, no, Joshua, I don't need to say the flag because in one of the lecture I already said clearly for CMP you don't need the S surface. It's always update the flag. So that's one is implied. Okay. So the most important thing I want to say here is the operation, right? Yeah, for the flag it's always updated. So we don't argue about that, right? So in this case, yeah, I got a sympathy for you, but but probably you will lose 2 points over here, and only 2 points. It doesn't matter, right? Only 2 points. Okay. So any other question? Otherwise, I would like to stop here, and I will see you next Monday to continue with the fixed point and floating point number. Okay. Any more last question over here? Okay. So it seemed to me nobody. Okay. So thank you very much, and I'm glad that you are. I mean, all of you. I mean, you did well on the second midterm, so that's good. Okay. So keep doing that for the final exam, and you will be fine. Okay.
Is the midterm part 1 and 2 considered separate or collected? As in,
I will add the two together
for the total score. Then
yes, for the total score. Yes.
Okay.
Yeah.
I just wanted to verify that so that way, because adding them together actually improved my score.
Okay. Okay. Bye bye, everyone.
All right. Have a good day.
You too.
Thank you.